So if we open our Notability here, and I'm going to add on to, we started in our last class, we were doing the free falling objects, but I'm going to add our notes today onto the polynomial section because there's a tie-in with the polynomials that I'm really hoping we can make here today. So I'm going to open up the polynomials and talk a little bit about where we were. We were writing equations and talking about end behavior, talking about leading coefficients and things like that. So for example, on this particular graph, the end behavior, they go in different directions. And that means that I should have an odd degree for this, which I do, because 2 plus 1, it's a third degree polynomial. 3 is an odd number, so that makes sense. It also goes down and to the right, and that is indicated by the leading coefficient being negative. Okay, so that all makes sense. And then the roots are here. So my x plus 4 came from that root, which was at negative 4. And my x minus 2 came from that root. And notice it's squared because it bounced. So we were talking about those. Let me give you another example that's similar, but maybe an even degree. Yeah, this is an even degree here. So this, because the endpoints go in the same direction, it has to be an even degree. So it could be second degree, fourth degree, sixth degree, or whatever. This one turns out to be a fourth degree polynomial. So that part adds up. And the right side goes downward, and that's indicated by a negative a value. Our roots, because we had a root at negative 5, that gave us x plus 5, and it's squared because it bounced there. And we had a root at 4, and that gave us x minus 4, and it's squared because it bounced there. All right, so we had a pretty good start in graphing those polynomials. So now I'm going to give you another skill that's going to help us graph these polynomials. And that skill will be synthetic division. So synthetic division is going to be dividing for polynomials. Now here's why we use synthetic division. If we have a function f of, I'm going to erase this in just a second, by the way. So don't write this down. I am going to use this function. But let's say we had the function f of x is equal to x to the third minus 9x squared plus 11x plus 21. Okay, if that was our polynomial that we wanted to graph, that does not look like that. It doesn't look like this one. It's not in factored form. So synthetic division is going to help us factor this thing, which you guys are good at factoring, second degree polynomials, or second degree trinomials more specifically. And we factored some binomials. But these polynomials, we haven't factored much. In fact, some of us have not factored those at all. But we're going to use synthetic division to do that. So here's how it works. Let's write down this example. So given, and I'm going to rewrite that same function. So given that f of x is equal to x to the third minus 9x squared plus 11x plus 21. So that's going to be our function. And let's say we know that x minus 3 is a factor. So we're given that f of x is x cubed minus 9x squared plus 11x plus 21. We know that x minus 3 is a factor. We want to write f in factored form. All right, so we already know part of our answer. We know this much so far. We know f of x equals x minus 3. It told us that x minus 3 is a factor, so that's one of them. But we don't know, we're going to have other factors also. We might have 2 more, 3 more, or whatever, but we have to find those other factors. Okay, so I'm going to later on be filling in those marks. And we're going to use synthetic division to do that. So here's how we use synthetic division. We take the opposite of that number, which is positive 3, and we put that in the upper left corner of a little chart that I'm going to make. And the chart uses these leading coefficients, which are 1, -9, 11, and 21. So I'm getting those leading coefficients from here, and I'm going to list them out. 1, -9, 11, and 21. And then I'm going to put a line here. So I know that that looks kind of weird, but this is how our synthetic division is set up. So again, I got that 3 from here. It's the opposite of that term. My 1 came from there. -9, that was that coefficient. 11 was from there. And 21 was from there. All right, so I'll do this a couple times because it might seem confusing at first. But when we do this, the first number, the 1, we just bring straight down. And then we're going to take the number inside this box 3 and multiply it by that number and put it there. So 3 times 1 is 3. That goes underneath the -9. So we multiply and then add down. So I'm going to add down -9 plus 3 is -6. Multiply the 3 times -6 is -18. Multiply and add down. So 11 plus -18 is -7. Multiply 3 times -7 is -21. So multiply and add down. So once we get 0 on the end, and we should get 0 on the end, that means that our leftover stuff, this, is a quadratic. Those are the coefficients of the quadratic. So that 1 is going to be 1x squared minus 6x minus 7. So the 1x squared minus 6x and minus 7, those were the numbers for our quadratic. And we're then going to factor that quadratic. So that factors into x minus 7 times x plus 1. And those are our answers. So we factored that quadratic. And then I'm going to take them, and those are our answers. They go up there. So it's x minus 7 times x plus 1. And there it is in factored form. All right, so I just threw a lot at you, and we'll do a couple examples, but what we want to do is we want to take something that looks like this and factor it so it looks like this. Because once it's factored, now I know the roots are at 3, 7, and negative 1. So I can graph the roots, the x-intercepts. I know that it's a third degree polynomial because x times x times x would be x to the third. So the ends are going to go in different directions. The leading coefficient is positive, so the right side's going to go up. So I could graph that. All right, so to restate the process this is my synthetic division process. It told me that x minus 3 was a factor, so that gave me this little 3 inside the box. These leading coefficients came from here. And then in that synthetic division process, I brought the first number down, multiplied, 1 times 3 was 3, and add down. Multiply 3 times negative 6 is negative 18, and add down. Multiply 3 times negative 7 is negative 21, and add down, and we got 0. So that then gave us our coefficients, which I wrote as x squared minus 6x minus 7, factored into our two factors, and those guys completed our answer. How are we doing? All right, good. All right, so that's a lot. Let's do another one, okay? All right, so given f of x is equal to x to the third minus 12x squared plus 35x minus 24. Okay, so given f of x is x to the third minus 12x squared plus 35x minus 24. And I'm going to change wording just slightly. And let's say that f of 8 is equal to 0. Okay, that's basically the same thing we did in the previous problem, and I'll show you exactly what that means. But all we want to do is write f in factored form. Just like we just did, okay? All right, now, this wording was a little different, that f of 8 is equal to 0. All that means is that x minus 8 is a factor, okay? X minus that number is a factor. So that's like the first part of our answer. We know that f of x is going to equal x minus 8. And then we're going to have to do some work to figure out the other factors. That's where the synthetic division comes in. Okay, so for the synthetic division, I take 8 and then the leading coefficients there, which are 1, negative 12, 35, and negative 24. And I'm going to do my synthetic division with those numbers. So we're kind of like in the last one, okay, in this step here where we're trying to do that synthetic division stuff. So remember to do that. We multiply the numbers and then add down. So I'm going to bring the first number down. So don't forget to do that. Bring the first number down, then multiply 8 times 1, which is 8. And then I'm going to add down. Eight times negative 4 is negative 32. And we're going to add down. 8 times 3 is 24. Add down. And we got to get 0 on the end. If not, we made a mistake somewhere. Okay, so for all the ones we do, we'll get 0 on the end. So that's kind of a nice check for us to make sure that we're doing this correctly. All right, so now we have this, which is going to be x squared minus 4x plus 3. And we're going to factor that, and then that's going to complete our answer. So that factors into x minus 3 times x minus 1. We'll put those up top, and then that's going to give us our answer. So x minus 3 times x minus 1. So we've written it in factored form. And so to throw a little more vocabulary at you guys, you know, this x minus 8 is a factor, which is saying the same thing as this because f of 8 is equal to 0. It also means that 8 is a root. So if the question was like, find the roots, I have 3 roots. I have a root at 8, 3, and 1. Okay, those are my roots, 8, 3, and 1. So I'm going to do one more example, and I'm going to have you guys do a couple. So, and I'm going to word it that way about finding roots. So let's say in our last example, all right, given that f of x is equal to x to the third minus 6x squared plus 3x plus 10 and x plus 1 is a factor, we're going to find the roots of f. Little different wording, but we're going to solve the problem the exact same way. Okay, we're going to write it in factored form, and then the roots are just the opposites of factors. So given f of x is x to the third minus 6x squared plus 3x plus 10, and x plus 1 is a factor, we want to find the roots. So to write it in factored form, we already have one of the factors, f of x is equal to x plus 1. We're going to have to fill in the other two parts. And I know there's two of them because it's a third degree polynomial. So we'll do our synthetic division by taking -1 and the leading coefficients, which are 1, -6, 3, and 10. And we're going to do synthetic division on that. So we'll bring the first 1 down. Multiply, -1 times 1 is -1, and add down. Multiply, -1 times -7 is 7, and add down. Multiply, -1 times 10 is -10, and add down. And remember, we get 0 as our answer, so that means that I've done it correctly so far. If we got something other than 0, then I just go back and I try it again. Because a real common mistake actually is that sometimes students will put like a +1 there instead of a -1 or just forget. So that helps us be careful on that. But I now have the leftover stuff. That's going to be 1x squared minus 7x plus 10. So that's going to be x squared minus 7x plus 10, which I have to factor. That factors into x minus 5, x minus 2. And then those go in up top to complete our function here. So x minus 5, x minus 2. All right, but last but not least, remember this said find the roots. So even though I have this factored, that means my roots are -1, 5, and 2. So my roots are -1, 5, and 2. So just be careful that you're answering the question as to what's being asked. If it says to write it in factored form, that would be our answer. If it says find its roots, then that will be our answer. All right, I'm going to have you guys try some in just a second. Before I do, and while I have this up here, is there anything you'd like me to go over before I let you guys loose to try a couple on your own?
Is it possible to end up like without a 0?
Without a 0 here?
Yeah, like you end up with something other than a 0.
Yes. It is not possible for all the ones we do, and that's because if this number is a true factor, you always get 0. And since I'm always going to be giving you a true factor, then you always end up with 0 there. Good question. Anything else? No. Okay.